successfully.
Hello guys, hello everybody, hello Philippines, hello world. So we will be able to discuss another topic, okay, but before that, before summarizing the topics of chemical reaction kinetics, which is under the physical chemistry, so the last topic is enzymatic kinetics, like that. Okay, about enzymes, right? About the enzyme and substrate chemical reaction. But before going to another topic, okay, we'll be able to have example one problem. Okay, it's not difficult. It's just like that. You have to analyze well, and then you can readily use the equation and formula being presented in the Michaelis-Menten equation. The only difficult class is the derivation of the standard formula, really, because you have to correlate basic concepts of the chemical reactions involved. Especially in Michaelis-Menten equation, we have the reaction of a substrate and an enzyme, okay, to produce products, something like that. And this principle is very important also in our immune system, in our body, how the antibodies will react to the white blood cells, to the vitamin C, and to the antioxidants, to the flavonoids, which are all under medical influences to really fight those microbe diseases, okay? Microbes that can cause disease inside our body. So through that, they need an enzyme to speed up the reaction in order for these microorganisms, virus and bacteria will be killed, okay? So if you have a strong immune system having an adequate level of vitamin C, which is specifically the ascorbic acid, the chemical composition of vitamin C, plus effective white blood cells, plus the antibodies in your system, then there's no way the virus can attack you, okay? 101% sure, even you are not vaccinated, okay? So prevention is better than cure, okay? Vaccination is only a cure and a treatment, but not a prevention. It is not an assurance, because the virus will multiply a billion times and it will produce various strains during the mutation process of those viruses. So all we have to do, but it's okay, it's an advantage also that you are vaccinated, so that it could help also, okay, as your defense. Aside from taking the health protocols from the government, of course, it can help you also. But what I am pointing out, it's not really unnecessary to do vaccination, okay? Meaning to say, not mandatory, okay? That's why the government also do not have that mandatory, because legally, due to that concept in science also, okay? Even if you're not vaccinated or not, if you are just taking care of yourself, having a good health and a strong immune system, it will never attack you, 101% sure, okay? Like that. Plus your health, hygiene measures, the way how you carry yourself, okay, to, you know, to get rid of this microorganisms or any, you know, germicidal actions, bacteria, whatever, so you will be not exposed to this, oh my gosh, deadly living organisms, then it will not have a chance to attack you in the first place, okay? Because the point of contact is very important, just like in OSH, the point of contact is very important. There will be no injuries if there's no point of contact at all, okay? If you'll never use a hand tool, an equipment, a machine, then it will not harm you. It will not cause injury because there's no point of contact. Just like that, also the principles between a human body, between the microorganisms, or what we call those, you know, microbes, okay? Gonna be like that. So we have a full freedom to be vaccinated or not. Let's just make it clear, okay? So it's only an added advantage to those very lazy persons to maintain their health protocols also, especially there are people who are very busy, right? Then they could not have time to have a perfect health hygiene measures. That's why they are vaccinated, at least. Okay, so, but it doesn't mean a prevention, okay? Just like us also sometimes, due to our work, sometimes when we get home, we will sleep immediately. We could not sometimes wash our feet. We could not sometimes take a bath for the second time because we are very tired already. Something like that. So it's very also helpful to be vaccinated. Okay? That's very clear. And this topic is related to that because an enzyme is a catalyst to speed up the reaction. Okay, in order our organs, for example, the brain, the digestive health, digestive meaning the large intestine and the small intestine, the kidney, the pancreas, the brain, the heart, the cardiovascular part of inside our body, the endocrine system, what else? Liver. Oh, liver will filter all the toxins inside our body so that we have a very good metabolism. Okay, something like that. So these organs need enzymes, okay, to protect our immune system. And this topic is very important. This is enzymatic chemical reaction kinetics. Okay, so the enzymes inside our body, the substrate plus the enzyme will produce a reaction inside our body. Technically, okay, like that. So chemical engineers are studying this also. Okay, and of course the chemists, the biochemists, and some medical professionals, medical technologists are studying this topic also. But I don't know really exactly what topics they are tackling with because I'm chemical engineer. Okay, I'm not in the health professional. Okay, so our topic, as I promised, I'm going to give you a problem. Okay, just like that. Okay, just to point out this trait, enzyme is equivalent to a catalyst. So what is a catalyst? For example, if you have a factory, a plant, a company that will produce certain product, okay, somewhere along in the processes, for example, within the processes, could it be a physical separation processes or chemical separation processes? It depends on what plant or company you're working with. There's a lot of processes involved there. There's heating, there's pyrolysis, catalytic cracking, okay, distillation, crystallization, drying, mixing, mixing of different raw materials, something like that. It's gonna be like that, and it needs catalyst to speed up the rate of reaction. This catalyst will never be consumed, it will never be used up, but will only increase the rate of reaction. Could it be a solid, liquid, or a gas? Because normally in a plant or company or factory, your products will depend on what phase. For example, I'm producing a cement product, so your product is a solid phase. I'm producing methane gas in a petrochemical or in a petroleum industry. So your product is gas. And then if you are going to produce an ethanol or a beer or a whiskey, then your product will be a liquid. So liquid, solid, and gas are all states of matter in chemistry. So it could be like that always. Okay? Or a mixture of liquid to solid mixture, a gas to liquid mixture, something like that. Depends on the situation. But what I'm pointing out is 3 phases of matter will always be there. Okay? Like that. So it involves catalyst to speed up the chemical reaction, something like that. In our body, the equivalent is an enzyme also. It will catalyze the biochemical reactions inside our body in order we will become strong. Our organs will work effectively through these enzymes. Okay? So this topic is very important. This is enzymatic kinetics discovered by Michaelis Menten in 19, I forgot the year exactly. Could it be 1934? It's prior to Eyring and but I think so. Never mind the year. The important is their discovery in science. Okay. Now, I have one problem here. Okay, determine the initial rate of an enzyme when conditions are such that the substrate concentration used is enough to produce half of enzyme's maximum rate of 40 micromolar per second. If the enzyme is 10 millimeter, determine the rate of catalyst or the catalytic constant K-cut. Wow. My gosh! Some of you guys cannot relate, okay, but you know, if you try to dig it up, it's very challenging and enjoyable to, you know, to go over, especially if you are along with me from the first to the last or within my course of discussion, because it's really enjoyable. It's all about science. Okay? Okay, what can we do this? We don't have to derive here, because we already derived the specific equation of Michaelis-Menten equation. Okay, so what's that? Okay. Oh my gosh. I could remember exactly when I was in college for this in our chemical reaction engineering, okay, and physical chemistry subjects. Okay, my gosh. It's very good to refresh, right? Okay, shout out sa mga chemical engineering students out there and Bachelor of Science in Chemistry. This is our line of expertise. Oh my gosh. Okay. We will use, okay, the proper way of solving a problem. First, you need to illustrate the graph or whatever, it needs a graph, something like that. In this case, we cannot use the graph because it's highly theoretical, not experimental. Okay, but if we try to use the graph, we can have the theoretical aspects already, meaning proven and tested that that's gonna be the way how our graph looks if we plot the initial concentration versus to the velocity or the rate of this enzymes, something like that. Guys, in this topic, enzymatic kinetics, guys, the rate is being equal to the velocity. As we can remember in science, in our high school science, when you talk about the rate, it always involves time in the denominator, just like the velocity, something like here, the rate of chemical reaction, meaning how fast and slow our chemical reaction really is. So it involves velocity or movement or motion. So technically, it's just the same, okay? But in terms of the concentration of our reactants converted to the product, something like that, okay? So velocity is the rate of change of the displacement, meaning the displacement over the time. That's velocity, right? Because speed is distance over the time. Speed doesn't account the direction of a certain quantities to be studied well. Okay, but for the velocity, the direction has been considered because we consider the vector quantity. Okay, both the direction and the distance covered, something like that. If you can remember your physics, okay, physics, the study of matter and energy. It's a branch of science that deals with the study of matter and energy. And you can easily understand energy and matter in that subject. Since we are not dealing here with physics, I'm just trying to link the behavior of this enzymatic kinetics. It also involves a velocity somewhere along the way. For example, if we eat rice, egg, in the morning, there's a reaction involved inside our body in which we cannot see. There's a motion or movement. So those biological substances, for example, carbohydrates, protein, vitamins or minerals, they are reacting inside our body. They undergo motion and movement. So there's a rate and velocity technically inside our body during the digestion process. Okay, the extraction of nutrients to be delivered in certain organs inside our body so that we will become strong and active day by day to perform our task. In work, we can dance, we can sing, we can read, we can watch video, we can do exercise. So all our senses will be active or energized through this process. And enzymes are very important for that because they speed up the rate of the reaction inside our body. Without enzymes, all of us will die. Okay, again, without enzymes to catalyze the chemical and biological chemical reactions in our body to produce energy in order for us to survive, then we will die. Okay, if our enzymes will be equal to 0. Okay, so those people who are sick, their enzymes are not properly working. Okay, because there's no substances to speed up the rate of reaction against all those bacteria and microorganisms or viruses that will help them to be killed. Okay, so if there are strong substances to fight this bacteria, then they will not be able to get sick. They will not be in the hospital. Okay, something like that. That means their enzymes are not working properly. Okay, or the lack of enzymes inside their body. And these enzymes are dependent to the nutrients we take inside our body, to the vitamins we take inside our body, something like that. Because they're also dependent to this nutrients, vitamins, and minerals in order for these enzymes also to work properly, or else there will be no chemical reaction inside our body. Okay, to maintain our health immune system. It's gonna be like that. There's a science chemistry or biochemistry inside our body if we take into account the physiological reactions in the anatomy inside our body. Okay, and we have to understand this. Okay, technically, if we are really, this is not really also obligatory, or this is not also mandatory to study. Usually, chemists, chemical engineers, biochemists, or health professionals are the ones studying this particular topic, so that we can understand really how to prevent against any diseases. Okay, something like that. Okay, to have a straight record for that, guys. When I was deployed, okay, in 2019, I forgot to bring medicines. Right? I don't have medicines now. Zero. I don't have paracetamol, any medicines, but thank to God, I am not really affected to these diseases. I don't know why, because I take care of myself. Okay, the hygiene, and I also know chemical reactions. Okay, I am very sensitive to those chemical substances inside my room, and I have to. Oh my gosh, I applied the science in my day-to-day life. That's why, oh my gosh, I am very thankful to God. I was not really, defeated by these diseases, even though I have no medicines inside my pocket, inside my cabinet, inside my box. Zero medicines now. Really, it took me 2 years to have that attitude. Imagine 2 years, no medicine, zero. And then I don't have any diseases. Okay, so it looks like, oh my gosh, I'm very blessed. Because, if you try to apply science in your day-to-day life, it's a very, very great help. Even though you don't have multivitamins with you, if you don't have medicines with you, or any cure and treatment with you, then bingo, because you know the chemical reactions. Really, I'm telling you guys. I'm not telling this because I'm a chemical engineer. I know the chemical reactions. But I'm telling you, if you know really the science, the basic science in your day-to-day life, then you can prevent diseases coming from you, or to be reacted with you. Because you know really the principles for that. You can prevent. And this bacteria and microbes really needs the outlet for them to stay well. Outlet. Meaning if there's no outlet, then these microorganisms, bacteria, and virus sure will never attack in your immune system. Okay, outlet. Meaning the free radicals inside your body. Meaning those lone pair of oxygen. Okay, this free radicals class, this is the outlet of the virus and the bacteria. Now, if your free radical inside your body is stable, okay, meaning completely shared with other electrons and ions when you take water, when you take food, there's no chance this bacteria or viruses will attack in your health system. Really. That's why this bacteria and virus will attack in your system, because you have so many lone pair oxygen atoms that is not stable. Okay? This lone pair of oxygen, guys, will destroy your cells in your organs because they will try to be stable. Then they have no pair. There is no bonding at all. If you remember chemistry, they need covalent bonding. Non-polar covalent bonding in order for these oxygen atoms to be stable. Okay? Imagine, day by day you drink water. You add oxygen molecules inside your body. Remember? And then this oxygen will react to various substances in your body. Now, if this oxygen is in balance, and there's a lone pair, meaning unreacted oxygen with various substances, then it will become unstable. So this unstable oxygen will eat all the cells and tissues inside your organs, and then you will become weak. What will happen? There's a lot of free radicals inside your body. Then that's the time the virus and the bacteria will go inside your body. They will be very happy because there's an outlet for them to grow, to enjoy, to dance, and to sing. So what happened? You will be defeated by this virus and bacteria, then disease will come in. Okay, any kinds of, normally the disease will start initially at a very minimum level, but then if you will not stop it, then it will become average to maximum. And budding, that's the time any kinds of diseases or critical diseases will be inside your body. That's why you will be affected with this COVID-19 viruses, because you don't have an idea also how to prevent it. Then you need to study epidemiology for this. If you know chemistry, and then you will study epidemiology. Okay, meaning the prevention and controls of these diseases. Because you know, me personally, I know already the chemical reactions and biological chemical reactions. And my lacking only is the epidemiology part, because I'm not a doctor. Okay, so that's why I keep on studying, I keep learning day by day. I read like this, oh, this is gonna be like this. So it should be epidemiology plus science, because epidemiology is prevention. Okay, and controls of disease that will come to your body. That's why I'm very thankful to God. I don't have medicines within me now, but you know, I'm very healthy. Okay, thank you so much, Lord God. Oh my God. Okay, so going back to the problem. Okay, determine the initial rate of an enzyme. Okay, oh my gosh, so what is an initial rate? So we will take this as a VO, or initial velocity, something like that. Okay, in Michaelis-Menten equation, the addition of enzyme plus substrate, okay, we have this equation, VO, okay. It's really good to discuss if you know, if you really understand, right? Because it's very good, okay, it's very healthy to discuss if you know what you are talking, okay, if you know what you are discussing, and very applicable to the human body. Something, oh my gosh, it's gonna be like this. So it's very enjoyable, worth it, okay. Okay, so VO is equals to V maximum, okay, times the concentration of the substrate. Guys, the enzyme will never react to other various chemical and biological substances inside our body, if there's no substrate. Okay, concentration of the substrate. It could be any forms of minerals, vitamins inside our body. Okay, that's why other people are taking multivitamins. These are all contain substrate. Okay, and react with the enzyme, then bingo. It can help protect our cells and tissues inside our body so that our organs will become healthy. Okay, so V maximum times substrate times Km plus the substrate, something. This is the reaction, the formula that we need to understand inside our body, because this is biochemistry. Our reference is inside our body. Okay, so initial velocity is equals to the maximum velocity times the substrate concentration over the Km. What is a Km class? Km is really a measure of the enzyme's ability to react, or the affinity to the substrate. As I told you, substrate could either be a carbohydrate, a protein, a mineral, and vitamins, fats, acids that will come inside our body. Okay, plus the substrate. Okay, so we need to determine the initial velocity now. Then data. Okay, data are given. Okay, what is being asked is initial VO, and we need to put question mark. Okay, like this. Okay, initial velocity of enzyme needed to our body, something like that. Okay, and then the K-cut. What is a K-cut? Oh my gosh. K-cut is the rate constant of the catalyst, or catalytic constant. Because remember, enzymes have the same function of catalyst. That's why we need to determine the catalytic constant. Or technically, we can say also enzymatic constant, but we use the catalytic constant siya talaga in an equation. Okay, but we refer the same thing for that. Okay, we don't know, right? Okay, there are two quantities to be asked. The equilibrium, no, the rate constant of the catalyst or an enzyme, question mark, and the initial velocity, question mark also. Okay, now, how can we do this? Oh my gosh. So we have like this. No, in the given class, in a data, we need to think, okay, that we have another data here to support in order for us to solve, or else we cannot solve if there's no at least one data to account with. Okay, something like that. Okay, maximum rate. Oh, this is our velocity, maximum velocity of our enzyme. So Vmax is equals to 40. Oh my gosh, micrometer. The unit looks like strange. Micromolar over second. Andiyan na naman tayo, molar. It's a sort of chemistry. I love chemistry, right? Okay. So, like that's a 40 micromolar per second. So what is a molar? Again, in our chemistry, moles of solute per liters of solution. Okay, it's just the same. And we don't break that one here, so it just calls as capital M. Okay, like that. Concentration at a certain velocity of this enzyme travels inside our body. Something like that. And then, VO, we don't know. Okay, something like that. So we need to solve for the VO. Okay, like that. Now guys, in this situation, we have to have critical thinking. Critical thinking means we have to analyze well. It says, with conditions are such, the substrate concentration used is enough to produce half of its maximum 40 micromolar per second. So half, meaning half of its maximum velocity. So this is initial velocity. Initial velocity is 1/2 of the Vmax, something like that, okay? So VO is equals to 1/2 of the Vmax. Okay, this one. Okay? Okay, now, in this situation, class, we can say directly that the Km is equal to the substrate behavior. So Km, it's very clear, right? So Km is equal to the substrate behavior. So we can substitute directly the value of Km and substrate is equal. Something like that. So we have our equation. Another paper, right? Shout out to Zomeric Junjun Panilagaw, Van Els, if you are watching right now. Thank you so much for passing by. Okay, so we have, oh guys, really, VO is equals to Vmax, okay, times substrate. Hello guys, okay. I did not do vlogging yesterday. That's I'm very excited to vlog today. Okay, so now in the denominator, Km is just equal to S, the substitute S there. So S, okay, S plus S, okay. Algebra or basic math. Do the basic math for this. We have the same quantity, substrate concentration, then it's gonna be like that. VO is equal to the Vmax times the substrate concentration over 2 substrate concentration. Yun. So VO is equals to Vmax, okay, times the substrate concentration times 2 times substrate concentration. Guys, in this, we need to simplify further our equation. We have to cancel out the substrate S. So cancel that one. Okay, it will become VO is equals to 1/2 Vmax. Oh, I derived the same thing with the theory. So VO is equal 1/2 to the max is equal to here, right? VO or Vmax is equals to 1/2 Vmax. VO is equals to 1/2 Vmax. Is equal. Okay? So perfect. We derive it perfectly due to the concepts and principles of this enzymatic kinetics. Okay, so we will use this formula. Now we have values now. Okay, it's gonna be like that. Okay, rate is 40. Okay, now if the E is 10 millimolar, guys, dyan naman tayo. So how many millimolar to micromolar. And we need conversion factors to this. So, again, basic conversion factors in algebra. Okay, mathematics. Oh my gosh. You need to memorize all the conversion factors. The metric system, the English system also. Okay, so that you will not be in trouble how to convert one quantity to another quantity, something like that. And you can easily cancel out or somewhere out of the way of your formula of equation. Okay. Now, our Vmax class is 40. Okay, and we need to convert this out to millimolar. Okay, like this. Okay, 40, convert. This is the Vmax, right? So Vmax, okay. Max is maximum, ha? Shortcut lang ni siya. So Vmax is equal to, like this, 40 micromolar per second. This class, 40 micromolar per second. Guys, we have a conversion factor which is 1 millimolar is equal to 10 raised to the power 3 micromolar. In this conversion factor, we can solve this micromolar to millimolar to agree or our units. Or it's gonna be the reverse, micromolar to millimolar, then millimolar to micromolar. But in this case, we need to convert millimolar to micromolar, then it's gonna be like this. Okay? Our E, our concentration of the enzyme is 10 millimolar. So we have concentration of an enzyme 10 millimolar. 10 millimolar siya. There's no second, guys, because this is not rate. Only the rate and velocity have second in the denominator. Remember that always have. Okay, so now convert. Convert this 10 millimolar to micromolar. Okay, let's do conversion factor. So 10 millimolar times 1 millimolar is equal to 10 times 10 to the 3 or 10 to the 3 directly micromolar. So cancels this out. We have micromolar. Okay, very easy. Okay, I think it's gonna be elementary level conversion factor to high school conversion factor. Okay, this is not yet a college type of conversion. Okay, like this. Okay, because it's been taught in our mathematics in elementary level or grade school level, and then in a high school level, senior high level, there's gonna be things like this. And then it is expected that when you are in a first year college, in the university or institution, you are mastering that out already. Okay, nobody taught you to how to do this because you mastered that already when you are in elementary and you're in the high school. So you should be, like that. You have the mentality to be like that, especially if you're taking up engineering courses. Okay, or science courses. Okay, so you should not depend in your first year college. Stock knowledge works here. Okay, so 1,000 times 10 is equals to 10,000. Okay, 10,000 micromolar. Okay, muna na siya. Okay, now, in our chemical reaction involving enzymes, I have to show the reaction now. So enzyme concentration plus substrate concentration is equals to ES. Okay, ganun-ganun siya, chuba-chucho. Okay, and this, it will produce to E concentration of enzyme plus P product. Okay, this is our chemical reactions in enzymes. Okay, concentration of enzymes E plus substrate concentration of S, reversible chemical reaction or rate of forward or backward reaction arrows. You should also know the arrows because this is a chemical equilibrium arrow. Okay, is equals to the combination of ES, enzymes and substrate, and then again, it will produce a product of enzyme plus the product P, in which we don't know. So it involves a lot of products somewhere along the end of the complete enzymatic chemical reaction. Okay, now guys, in here we have the total enzyme is equals to the enzyme that is being produced in the product ES and the enzyme being produced in the E plus P region, or in, okay, you will understand now. Total enzyme concentration is equal to the enzyme from the ES product. Look at the chemical reaction so that you can understand. I interpreted it that way. So total enzyme, capital E, is equal to the enzyme in the ES part plus the enzyme in the E plus P part. So we can have like this. Okay, AT is equals to reversible again. Reversible chemical reaction is equal to, oh, I love reversible chemical reaction. Okay, like this. Okay, like that. Oh my gosh. Okay, ES. Okay. Then actually guys, this is plus E. Okay, according to mechanism principle guys, okay, it's gonna be like this, ha? This is the complete chemical reaction na talaga siya. Narrowed down into AT chemical, reversible chemical reaction, ES plus E. According to mechanism principle, the capital E in the product of this last equation presented to you guys, or chemical reaction, will be negligible and irrelevant already because too small to consider. Okay, and it doesn't contribute to the stability of your chemical reactions. So it will become zero somewhere along the way. Okay, it will become producing another products, and then it will disappear all throughout your chemical reaction because the value or the molar concentration of this E is very, very small na talaga siya. Okay, because it has not been reacted to the substrate. Wala gid siya partner, wala siya uyab, wala siya jowa. And then, nag-inusara lang si E. Okay, if you try to put that in this situation, then this E will become lonely, will become depressed, wa siya jowa, wa siya uyab, then this E will become zero na siya somewhere in your chemical reaction. Intindihan? So, E is equal to zero. Of course, if this is not stable, he has so many problems, very sad, and you know, so he will become zero na siya talaga. Okay? Just like that. An analogy lang talaga siya if you try to put that in a human being situation. Okay? Like that. So, now, total enzyme will become 2ES na talaga siya. Now, reversible chemical reaction, you have to put equilibrium rate constant. Remember, in phase equilibria topic in general chemistry lecture, and also in solubility product constant lecture in your chemistry. Remember that one, huh? Recall the stock knowledge in chemistry. Okay, something like that. So we need to add, shall we say, K2, because K1 and K2 is used here. Only 2 points to consider, not 3 points. Okay? Like that. So, it's very understandable, right? So K2, like this. Guys, I want to trace out this, huh? So actually this is K minus 2. Hala. And I have to explain this. Okay. Total enzyme is reversible chemical reaction, rate of forward and backward reaction. The forward reaction will produce K2 plus, okay, and the K minus 2 going back to the rate of backward reaction, negative 2. K negative 2. Now, this is also equal to K2. Why? Because guys, there's no other chemical reactions involved. This is a straightforward chemical reaction in which ET is directly converted into ES. So, by chemical equilibrium principle in chemistry on a steady state flow, abiding the law of conservation of matter in chemistry, okay, we can say K2 is equal to K minus 2. So therefore, the negative 2 will just be equal to K2. The rate of forward reaction is equal to the rate of backward reaction. So in this case, the sign is no longer relevant. So we can say K2 is just equals to K2. It's no longer minus 2. You understand? K2 is equals to K2 na talaga siya because in equilibrium stage, abiding the law of conservation of matter. Instead of putting K minus 2 in the rate of your backward reaction, arrow pointing to the reactant, then we can say also as K2 na talaga siya because they are equal with each other for the reason there are no other chemical reactions involved. This is straightforward in a reversible chemical reaction. So, K2 is just equal to K2. Now, in this chemical reaction, we need to solve the rate of each. So, I could say the rate of total enzyme is equal to the rate of the total ES. Okay, but that since ES is already product, you don't have to put T na talaga siya because it's already product after all. So it's just the E you have to put product because it is the enzyme works properly here in the entire chemical reaction. So now we can say, class, that R, okay, since K2, then we have also to put subscript 2. So R2, okay, R2 is equal to, okay, the Vmax. Why the Vmax? Explain, Sir Sotero. Why the Vmax? Okay. Okay, the Vmax or the K2. Okay, later I will explain to you to that. So AT. Okay, like this. AT. Okay. R2 is equals to K2AT, meaning to say the rate 2 is equal to the rate constant 2, rate of forward reaction K, rate constant, times the concentration of the reactant enzyme total AT. Now you will also get also the another K2 in which equal na talaga siya. So if equal na talaga siya yung K2, R2 pa rin siya. So R2 is equals to the K2 again because they are equal. K2, and then the K2 here is already now the backward rate of reaction. Look at the arrow. It is pointing on the reactant. So it's gonna be na K2 times, say pares niya. It's gonna be ES na siya, not ET. Okay? K2 times the concentration of ES. Okay? Like that. Okay. Now you will determine, class, the Vmax and the VO here. Because as I told you in my introductory part, rate is just a velocity. Okay, which is the initial velocity here? And which is the final velocity? Okay? Like that. Initial velocity in this case, class, initial velocity is equal to the final velocity. Rate initial equals to the final rate because this is equilibrium. Okay, there are 2 points only to consider. Direct, reactant direct to product. There's no other chemical reactions involved. That's a reversible chemical reaction. So how can you say that? How can you determine, how can you distinguish the VO and the Vmax here? Because our formula of Michaelis-Menten equation have VO and Vmax na talaga siya. See? And then we arrive VO, initial velocity is equal to 1/2 Vmax. Oh, diba? So, how can we do that? Okay, so we can say, let's assume, because I don't memorize, okay, I assume that the maximum velocity is the one it will go to the AT, right? So the one it will go to the AT, so I could say that R2 is the Vmax. Okay? Let's try. Or you can try also the reverse. Let's assume that it's gonna be K2 ET is the Vmax. Because that's total. Okay? Like that. Because I did not go this farther talaga siya eh. On the spot. Okay? I write the problem, but I don't go over to this kind of interpretation just now. On the spot. So that's why I try to tell you, well, let's assume this one, and let's assume, because I did not memorize the way it is being solved. Okay, like this. So on the spot. So oh my gosh. So V maximum. Let's say na lang talaga siya na total enzyme ko. So V max. Okay. Ganun siya. And then if we will fail this one, we need to reverse, right? This is assumption. It's part of science, right? We need to assume. That's why we have trial and error method in the laboratory experimentation. We have to repeat our experiments if our experiment is not proven to be true, valid, and correct. That's gonna be science all about. That's why some scientific research and discovery, it took a lot of years to prove, to have a scientific law and scientific equation. That's gonna be the process of scientific way. Okay, so it's just like that. I'm employing the quality of being a scientist. Okay, we need to assume first half. So V maximum, okay, is equals to ano lang talaga siya. Okay, to anyway, we can reverse this one somewhere along the way if our assumption will be not valid. Okay, K2 times A2, AT. Okay, I don't want to be perfect. Okay, it's gonna. I don't have to have a perfect blogging. It's gonna be scripted, right? Okay, so R2 is equals to V max times K2. Let's assume that R2 is your V max and also your R2 will be your VO initial because equilibrium kasi siya, diba? So VO is equals to K2 ES. Okay, guys, equation 1, equation 2. So we arrived another equations through these assumptions. Okay, like this. We arrive to another equations due to these assumptions. Okay, the Vmax and the initial velocity. Now, what is again your problem, guys? Is to solve for the K-cut. What is the K-cut and what is your initial velocity? Now, if we substitute the value of K2 here and the ES, we can solve for the VO, right? And we don't know yet talaga siya. So the first thing to do is to solve for the value of this each. And the guys, K2 is technically equal to K-cut. Why? Why? We need to ask why. Okay, in your chemical reaction, in the final reaction, K2 is the rate constant. Because this K2 is the catalytic rate constant to speed up the reaction so that we can complete the chemical reaction. So you introduce a catalyst. Okay, even though this is a K2, it will now be equal to K-cut. Directly. So your equations here, class, will now be equal. Initial velocity is equals to K-cut times ES, and the Vmax is also equal to K-cut times the ET. Okay, now, and now you have the 10,000 micromolar already as your E or your ET in the Vmax computation in the top portion, right? See? Top portion here, ET. Okay, ET is now the 10 millimicromolar. Okay, you substitute this value. Okay, here in your equation. So, which of the two involves ET? It's the Vmax, right? It's not the VO. Okay, so choose the applicability now to substitute your values. Okay, so the best way for that is to do algebra. Okay, algebra or basic math. So, we need to go for the equation 1. So, instead of K2 class, we need to use the K-cut na because they are equal man in principle. Okay, so Vmax, use equation 1 to solve for ET or total enzyme. Okay, like that. Or to solve for the Vmax. Okay? Or to solve for the K-cut. It's gonna be like that. There are 3 quantities, then you have to solve the 3. And if it is given, you have to solve the other. It's just like that, okay? So, oh my gosh. Okay, so Vmax at equation 1. Sorry guys, I'm taking too fast. Okay, in my discussion. Okay, because sometimes I need to be spontaneous because, you know, it will be lost in my brain cells. The theories, the concepts. Then just object me if I'm talking too fast. Then I have to adjust my velocity in this discussion. Velocity, the way I present the discussion. The movement or the motion of my discussion. Okay? Like this. How slow and fast my discussion really is. It involves also rate, right? Rate of discussion. Velocity of discussion. Okay? Because it involves time per second. The way how you deliver your discussion. So, just like here, right? In the enzymatic kinetics. So, at equation 1. Okay, now, this is now equal to Vmax. Okay, max is maximum, ha? Direct na siya. Is equals to K-cut. Okay, K-cut times A total. Okay? Like that. Okay? Now, this gonna be like this na talaga siya. So, V maximum is equal to the K cut times the total enzyme based on the equation 1 presented here. Okay, no, substitute values na talaga siya. Okay, our ET above is 10,000 micromolar. Okay, now, and our Vmax also is, we determined that, okay, already as 40 micromolar. It's very clear. So Vmax, 40 micromolar per second. Okay, ET, 10,000 micromolar, and these two quantities are here in this equation. Then bingo, we can solve for K-cut. Okay, you know, elementary mathematics. Okay, K-cut, something like this. It doesn't involve calculus. Okay, calculus and, you know, differential, integral, you know, the attack of solving is very, shall we say, easy. Okay. Like that. Okay? Remember that, guys, ha? Ano yun siya? Algebra na yun kayo siya. Okay? So, since I love algebra, I can solve this properly. Wow. Okay. Because, you know, I don't love calculus, that's why. Okay, so Vmax, so it's gonna be like this. K cut is equals to Vmax over the ET. ET is the total enzyme concentration. Now, K cut, so we can solve now what is being asked in the problem. Okay, K cut is equals to Vmax over the total concentration of your enzyme ET. Now substitute values. So V maximum is equals to 40 micromolar. Micro plus meaning 10 to the negative 3, something like that. Okay? You remember? It's gonna be 10 to the negative 3. Okay, micro man siya, diba? Okay? Like that. And then your milli, okay, something like that. So molar. Okay? You know, the units are strange also because we are not practicing this all the time. The units, because these are all enzymes talaga siya. Okay, smaller than those chemicals that we seen in the laboratory, something like that. This is more smaller, the micromolar or something like that. Okay, so ET is 10,000. Okay, micromolar na siya, so we can easily cancel the 2, ha? Okay, canceling the 2, what's left is 1/second. Okay, 1/second is the unit of a rate constant. Since K cut is a rate constant, then perfect. Our unit of our catalytic constant is correct. Okay, so K cut meaning catalyst. We need to short lang talaga siya, K cut, because it also took time to write everything. So K catalyst is the same as K cut. V maximum is the same as V max. Okay? So FYI lang. Okay? So 40, okay, just like in science, we always abbreviate things so that we can solve a little bit fast. Something like that. Okay? 40 divided by 10,000 is equals to, oh my gosh. Okay? So 4 times 10 to the negative 3. Okay? 4 times 10 to the negative 3. 1/second. Okay, this one, K cut. Okay? Like that. Be careful also for the negative sign, and for the positive sign in this manner. Because if the positive and negative sign will be wrong, then your problem, you will be wrong entirely. Something like that. Okay? You understand the point? So, K cut, or rate constant of the catalyst, is equal to 4 times 10 to the negative 3, 1/second. Or you can write that as also 4 times 10 to the negative 3 as negative 1. Because S negative 1 is also the same as 1/S in the denominator. Okay, so this is our K cut already. Oh my gosh. Okay. Again, review 40 divided by 10,000. Okay. On 80, Vmax over K cut. Okay. So that you can solve properly and correct, you have to review second time. Because you will be in error if you will not review. Just gonna be the procedure in taking examinations. 2 times review only, yeah? You don't have to review so many times. Because the more you review so many times, the more you will get error. Okay? Okay? That's gonna be the procedure of solving problems in engineering or any type of problem-solving questions if you are facing examinations in the future. Okay? Something like that. You need to follow the basic way of how to attack the problem. Okay? Don't be too fast, be slow, and then you're very eager and you forgot the principles and concepts, and then you will be confused somewhere along the way. Okay? Especially the signs effect. Plus and minus sign is very important. Okay, so 4 times 10 to the negative 3 talaga siya. Okay, your K-cut. Now, there is one required initial velocity. Now, you have the formula of initial velocity, which is K2 times ES, something like that. So, how can you solve for ES? This is in equilibrium. ES is just equals to ET. Bingo. Because this is in equilibrium in your reaction, guys. Okay. Equilibrium equals. So ES is just equal to AT. No need to solve for ES because it's equal in the principles and concepts. This is gonna be like this. For example, if you don't know how to analyze, then you will solve to ES. You'll think, oh, what's the formula of ES like this? But it is equal based on your chemical reaction. No need to find for the formula. So it's just equal to AT, which is 10,000 millimolar, something like that. Okay? So, initial velocity, charot. Initial velocity is equals to K cut K2. So, i-times ragyan mo siya ang value. Okay, times the ES, which is also equal to, pila na itong ET. Akong giingon, 10,000 siya. Equal ragyan siya. Okay, ganon. This is the first assumption guys. First assumption pa ni siya. Okay, so 10,000 times 0.004. Okay, 10,000. Okay, times 0.004 is equals to, did you ko ganahan basta na exponent kapit times is equals to 40. O see, equal siya, right? 40. Okay, so we have VO is equals to 1/2 of your Vmax as you showed before. Okay, then VO will be your maximum 40. So 40 divided by 2. Okay, molar second divided by 2. Our initial velocity is 20. Okay, 20 micromolar per second, something like that. And since you know VO is equals to Vmax with 40, like this, molar per second. Now take note. Take note. This gonna be, I love this, vlogging talaga siya, no? Hindot siya, okay? Because it is not perfect. Okay, what do you see in our first assumption? First assumption on the spot. Okay, try to take a look. In your chemical equation in my introductory part, I obtained VO is equal to 1/2 Vmax, right? Now, I obtained the VO is equal to 20 micromolar per second, and it's not equal to 40. So something wrong in my analysis in the first. As I told you in the very first time, you have to reverse if your assumption is wrong. I'm very consistent to that. Okay, so we have to reverse here, somewhere in your chemical reaction here. Okay, so it's gonna be like that. So we have to reverse. Our rate of forward reaction now will be Vmax is equal to K2 times ES. So meaning to say our Vmax is going forward. Because in our first analysis class, we analyzed that our Vmax is going to the reactant. That's our first analysis. Now our second analysis now, our Vmax will be going forward. Which is valid because if you go forward, that's positive. And you go backward, it's negative. So, we now have the second option like this. Di bang saya-saya? Hindi siya perfect. So, I love this. This is gonna be useful in understanding, okay? So, I want teachers and instructors to be like this, okay? We need to have assumption first rather than going directly to what is being desired so that the students can understand really. Okay, so since our first assumption, guys, in this chemical reaction, our rate of forward reaction is the V initial, then we need to reverse this one because in our chemical equation, it is not equal. I obtained a half of the, what's this? The VO, which is not equal to the VO. The VO in the theory is not equal to the VO in the actual solution. So there's something wrong. This is what I keep on telling you. This is the time concepts and principles works rather than solving without understanding. Okay, something like that. Okay, so since this is on the spot, I cannot guarantee a perfect, presentation right away, or else I could choose directly this Vmax going there. But since I understand, I can play around both. Okay, so now we need to say this as Vmax is equals to K2, and this is now ES. Okay, chararat. Okay, so Vmax is equals to K cut, okay, times, but sakto na to siya ang ang concentration, hindi mo matter, ano naman matter sa Vmax. Okay? The K cut will be equal na talaga siya because it is constant somewhere along the way. Tanawa na good na siya, di assume K2 is equals to K2 man good siya. So K cut is just equal even though the velocity assumption is reversed, right? So K cut is equals to ES. Forward reaction. You can see in the arrow. Ang arrow, guys, tanawan ninyo ha. Ang arrow sa chemical reaction, point man din to. So, muna siya atong Vmax. So, K cut times ES. Siya ang ES, umaman siya ang imong reactant good. Okay? In going there. Like that. Okay? It's gonna be like that. So, how can we do this? Reverse. Simply like that. Okay? Okay? So Vmax is equals to, okay, K2, forward rate of reaction, then ET, okay, ET, and then VO, okay, is equals to K2, and then the reactant will be the ES, okay, like that. Since in this case, guys, we obtain not the same ang good siya. Our VO, 1/2 Vmax, and our Vmax is 40 divided to 20 siya. And then our answer here, somewhere along in the way, is ano man siya. Saan na yung answer natin? Okay, it's lost. Too much paper! Okay. Nasaan na to siya? Nawala siya. Forgive me. Sana mayroon ako whiteboard. Okay. Saan ito na kung pisuwat? Ay, dara! Okay. Dara siya, Okay, mo siya nga, VO 1/2 Vmax, so 20 siya automatically without solving. Okay, now our Vmax is equals to, or VO is equal to, kanina siya itong gigamit, so VO is equals to, okay, K2 is equals to VO over ES. Okay, VO over ES, since ES is just equals to AT. Now, we will use the another way around. Okay, like that. So, our ET now, so we have a key cut. Okay, VO is equals to K cut times ES. Okay, like this. Okay, like, pila man ang value sa K cut atong na-solve. So, 4 times 10 to the negative 3. Okay, 4 times 10 to the 10 negative 3. Our ES is just equal to the, pila itong ES na nakuha nato. So, 10,000. Okay, 10,000 is equals to micromolar. Okay, VO is equal to like this. Okay, times na to siya. 10,000 times 0.004. 40! As you can notice, class, we still obtain 40 micromolar per second. So, Sotero, why like this? You will come to think, right? Now, I tell you guys, diba, I told you the chemical reaction in the last portion, chemical equilibrium. And I told you rate 2 is just equals to the rate 2 on the rate and forward and backward. Since it's also self-explanatory that your final velocity will equal also to the initial velocity because rate is also a velocity. So this is perfectly correct. Okay, 40 micromolar per second initial velocity is equal to the final velocity for 40 micromolar per second. Okay, and the assumption of Vmax VO 1/2 Vmax in here, in which we solve. Okay, this will not hold through because the P is not being considered already in this reaction. As you can remember, so the theory pala, it states that this VO is equals to 1/2 Vmax pala siya if we consider the P in the last product. But in here, we treat the last, not P, the E, we treat the E as 0 na talaga siya. You got the point? Tanawa na itong reaction. ET is chemical equilibrium to ES plus E0. Ang kani pala siyang principle na VO is equals to 1/2 Vmax, naapa ni siya E, na wala pa nato siya gi-cancel. Got the point? This theory and concept holds true if we have a value of the enzyme. But here, we don't have the value of an enzyme 0 because it is very negligible and we treat that as not considered na in our final reaction. That's why we told you ET is in equilibrium to ES. What is the value of ET? Is just equal to the value of ES. What is the value of K2? Is just the same also all throughout the process. Something like that. So, this is perfect. Okay, our velocity, initial and final is equal. Our initial rate and initial final is equal rate. And our K-cut also is equal to 4 times 10 to the negative 3 per second is also equal in the rate and forward backward chemical reaction because we are reaching chemical equilibrium. Okay, so if we reach pala chemical equilibrium, wala bad sa ulo because we don't consider the other products. It's only 1 will produce 1, something, or 2 will produce 2 as long as they are balanced with each other, something like that. And assuming that the values of each concentration are not negligible enough to consider. But here is negligible na good ang E, ang enzyme here. Okay, gizero ba yan nato in our theory here in the first, before ta nag-solve, di ba? Gizero na nato siya. Ang akong point is kung sige lang tag-solve, sige lang tag-solve, sige lang tag-solve, pero maglibog ta. Diba? Because I keep on using another just to prove na usa kay baliwan niya. Okay, so not knowing pala in my introductory part, it's already equal. So this is really proving and showing to you that theory, principles, and concepts hold through rather than keep on solving until such time you will be confused. Okay, so this is the main reason why some students are failing in the examination. Especially there are a lot of problem solving, just like me. I will not also pass if I am confused all the way, all throughout the problem solving, because there's a lot of problem solving in chemical engineering, okay, and in physical chemical principles. Though there's also a balanced theories questions, but it could not be denied. There's a lot of problem solving really, and it's really, you know, it really makes us crazy during the examination because we are just, you know, keep on imagining things that we cannot see in our naked eye. Okay, chemical engineering course is just like that. You can never see atoms, electrons, and protons like this radiation in your naked eye, but we keep on studying those stuffs in which we cannot even touch, we cannot even use. Just like an air, we can never see that in our naked eye, but we keep on computing what is the amount of this nitrogen in the atmosphere. So it looks like crazy, right? Since that is our course, then we don't have choice. Okay, something like that. And we can apply that also, the theory, in our real practice in the line of chemical engineering job in the future. That's only the thing that it makes us, to help us practice and apply that in the real world. That's only the purpose and goal. But we can never apply that or take that in our hands and see that the reactions are along the way, the beta particle, the gamma particle, the X-rays, or whatever, chuba chucho. In chemistry, we cannot really that see. Okay? Sometimes, that's why I told you consistently, if you want to become an engineer, you have a wild imagination. Especially in, you know, BS chemical engineering, you should have a wild imagination, okay, greater critical thinking, okay, and you have to understand all the formulas before it is arrived. Meaning you know how to derive those formulas and equations so that you can understand. And you have to memorize and understand all the basic concepts and principles in chemistry because it will be kept on using in your higher grade. Physical chemistry, reaction kinetics, biochemical engineering, unit processes, unit operations. It's still there. You should apply that theory. It will just modify the way the problem is presented, but the way how you understand the total picture is very important. That's why chemistry and physics are prerequisites in all your subjects in higher chemical engineering course subjects. Okay, you understand the point now? Okay, it's combination of physics and chemistry, but the foundation really is general chemistry plus mathematics, which are purely algebra and a little bit of calculus only, not that very rigid calculus. Okay, what I mean of a little bit, meaning for example, if there are formulas of calculus from let's say differential is D1 to D25, something like that. Integral calculus is I1 to I27, something like that. I could not remember. We can only use at least D1 to D5 formula. We can use only at least I1 to I7 or I2. But those all will never be used. Okay? That's my point. That's a little bit of calculus. Meaning to say, it will never use all the formulas presented in calculus subjects. Only from 1 to 5, 1 to 7. But bingo, we can solve now already the problem. But the algebra, it's really comprehensive. You need to understand what is a polynomial, what is an integer, what is the PEMDAS rule. PEMDAS rule. Okay, what is really a quadratic equation? Okay, what is really a slope equation? The y-intercept, the b-intercept. You have to understand. Okay, the slope. You have to understand the quadrant. Okay, quadrant 1, quadrant 2, quadrant 3, quadrant 4. You need also to understand the degrees of inclination. Okay, what is a 90 degrees? What is an 80 degrees? What is a 270 degrees? What is a 360? Because it can be used also in the physics, in the pressure is equals to force over area, then work is equals to force times distance, because force can be applied not only directly in horizontal. Force also can be applied through the degree of inclination at 30 degrees. 40 degrees, 50 degrees. And the problem will not stay all the time in horizontal applying of the force. That's why you cannot solve that through, normal force times distance. It could be force times distance, okay, times the angle of an inclination, 40 degrees. And remember, the formula also of Pythagoras theorem, because in that you can solve that there, the height. Okay, so hypotenuse squared, like that, the square root of the base squared plus the a squared, and the b is your length, the width, and bingo, you can solve for the hypotenuse. Okay, and since you apply the force in the inclination, then you can solve the value of the c or the h, then substitute that in your equation. In work is equals to force times distance cosine theta. Work is equals to force distance times sine theta. Work is equals to force times distance times tangent theta. And you should know what is the value of tangent theta. Tangent theta is equals to the angle of inclination theta is equal to the A and the B. Something like that. And then for the cosine theta is the, the horizontal distance over the hypotenuse theta. Ganon-ganon siya. It's not all the time horizontal in obtaining the work. Okay? So that's why you need to know comprehensively algebra and a little bit pala of trigonometry. I think trigonometry na mga angle-angle, di ba? And a little bit of geometry, the shapes. The shapes and the volumes are studied in geometry, and the angle of inclination are studied in analytical geometry. Okay? Like that. And algebra is studying that both also. Okay? The Pythagoras theorem of right triangles. Something like that. Then, put that in your brain cells. High school pa lang, memorize na talaga siya. So that, memorize and understand. So that in first year college, you will master that all throughout in your algebra. Because algebra will come back again in first year college, not only in high school. High school is in just introductory part of algebra. But in a first year college, there's a little bit of addition, but you should have the stock knowledge of those basic concepts so that you can really understand how to solve further. Something like that. Okay? Okay. Okay, ganon siya. If you want to take up engineering courses, science courses, okay, mamagin siya ang foundation. Okay, basic mathematics and science formulas, concepts, and theories. Okay, a lot of mathematics, but not that too difficult. But you can manage. Okay, but it requires critical thinking and better comprehensive understanding. Wow, comprehensive. What do you mean comprehensive? Meaning the details must be understood. Charot, must be understood talaga. Okay, mauna ni siya. Shout out to Rapi Cantel, Maricel Cabral. Thank you so much for watching this live streaming about mechanism maintain equation application of enzymatic kinetics. Guys, this computation of this okay, we can compute also, for example, what is the initial velocity of carbohydrate inside your body? So you can answer na, because this is the equation first of all. What is the maximum velocity of sugar inside your body? You can compute using this equation. This is the concept of this equation. And then, what is the initial velocity, for example, of your steroid hormone that will be going to your pancreas? Ganon siya. Okay, and mga ganon siya inside our biological chemical reaction. Kaya naman siya enzyme. Okay, so this formula will be valid inside our body. Because since nobody will ask you, what is the velocity of, sucrose inside your sugar, the table sugar we take in our coffee? Nobody will ask you, but at least we have an idea what is going on inside our body. There's a chemical reaction. We can really compute each concentration of sugar we take. Okay, each concentration of carbohydrate we take, each concentration of the fat we produced. Okay, we can also compute the vitamins concentration inside our body. Okay, the vitamin C, the vitamin A, we can compute also the concentration of minerals inside our body by using this mechanism maintain equation. Okay, so this is very applicable really if you try to compute mathematically, okay, the concentrations of what we take. Okay, so like that. And then because we are also having the dosage, every time dosage prescribed by the doctor, how many teaspoons, like that. There's an right? And then you have to write that in a piece of paper. We have to take 10 milligram of ascorbic acid, or like this. Okay, then you have to put that as your initial concentration. Ganon. Then you can solve for the final concentration. So this must be helpful also. Okay, since we have now technology in the laboratory, we don't have to do this anymore. Okay, because automatically these concentrations can be computed na in the lab. Okay, in the laboratory, in the clinic, in the hospital. That's why the doctors and the medical technologists are taking sample of your blood. Remember that one, right? So they can compute now what is the concentration of high density lipoprotein, the concentration of your cholesterol level, your triglyceride level, your sugar level. So actually it can be computed manually also by using this. You understand? You can also compute that manually by using this equation. But since we have now technology which is more faster, we don't have to do that anymore. My purpose in this vlogging only is to understand how to compute it manually without those technology. Okay? Ganon siya. Diba? Importante siya. Okay. Guys, wala na ako yung microphone. Charot, charara. Diba guys? Diba? What if your laboratory equipment and technology are all damaged and cannot function anymore? So how can you solve for the concentration of your blood, your cholesterol, your sugar? Then use this equation. Okay, so you can obtain what is the concentration of your triglycerides level that composed of the fatty acids, blah 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 blah. Okay, get the point? Ganun siya. And the glyceride level, glyceride or glycerol. Okay, so you can remember that triglycerides, sugars, are composed of glycerols or glycerides plus 3 components of saturated fatty acids. That are the combination, okay, of the triglycerides that the doctors are taking into your system, blood or samples, something like that. Okay, so there's a breakdown of that component. Triglyceride is just general, But triglycerides are composed of 3 components of saturated fatty acids, which are mainly stearic acid, and I can have the formula also to that, plus glycerol. I can have also the formula for that. I can understand really what is triglycerides all about. Okay? Okay? Like that. So it's not enough to understand triglyceride. We need to know, oh, what are the components of the triglycerides inside your body? How it is being abnormal or working properly, so that you can prevent diseases coming from in your body or coming to your body. Because you have an idea really, what are the components of triglycerides? What are the components of cholesterol? So you can understand, then bingo, you can understand how to prevent. Okay? Then control your intake. Because you know already what the behavior of this cholesterol, so that we can prevent diseases from coming in. Then, another method is to do hygiene, diet, exercise, complete good sleep, good rest. It can help also to become healthy. So those stuffs are very important really. Okay, to understand only the behavior and the components of those substances are only one thing to discover. But there's a lot. Okay, for example, sleeping early, enough rest, taking the vitamins, taking the good food you eat, personal hygiene, okay, like that. This I told you is only one area. A lot will be considered also, okay? So it's gonna be like that, okay? But it's very important to really understand the behavior of these chemicals that we take in, because these are very harmful if this is overdosage inside our body. So we need to, to troubleshoot, especially sucrose. White sugar is very deadly. Okay, so if we don't monitor our sugar intake through computation like this, so we need to compute the concentration of sugar we take in, solve the problem. Okay, actually we don't have to quantify how many sugar we take. We have only an idea what's going on, something like that. Okay, because I don't have also the measuring device. Here too, I have to measure the sugar, and I will take that one, and after that, I will measure my urine. I don't have the device that in my room, okay, but I have an idea really if it is already more than what is required, what is less than what is being required. So that's the thing, so that we can prevent diseases coming in, something like that, okay? So that's part of prevention. Prevention is better than cure, and I thank you. Thank you so much for this FB live streaming. Thank you so much for watching, guys. Bye bye, God bless everybody, and see you later for my another vlogging. It's related also to this, but more na on talaga on chemical engineering and sciences na talaga siya. Because this one, guys, is a little bit of biochemistry, the study of the life plus the chemical reactions involved, okay, in different organs inside our body. So this is more useful compared to the other parts which are more on the to be applied in the plant, industries, factories, that doesn't require, that's not required human body understanding of the chemical reactions. Okay, there's no blood chemistry in the production of cement. There's no blood chemistry in the production of petroleum, right? So that is not biochemistry. This one is biochemistry or biochemical engineering. Shall I say more important than those? Sorry to that, I am biased, right? No, even though I am a chemical engineer, I could still say this is more important, this biochemistry. This is only one part of our subjects in BS Chemical Engineering. But we are not going deeper to the biochemistry part. We are going on the biochemical engineering. Okay, but still there's a biochemistry part, but not very detailed on biochemistry part, but biochemical engineering, the study of life, plus the chemistry, plus the application of mathematics, plus the application of new technology. Okay, something like to have medicines so that we can prevent the diseases or the sick people. It's part also of study of chemical engineering, biochemical engineering. Okay, something, but we don't put more emphasis on the prevention part. Okay, but we have only a basic idea how to prevent having these concepts, principles of biochemical engineering, the biochemical reactions of biochemical substances inside our body, meaning chemical substances plus biological substances interacting inside our human body, in which the recipient are the brain, the liver, the pancreas, the endocrine system, the heart, okay, the liver, and other chuba chuchu. of the organs, okay, and the cells and tissues behind that. They cannot survive really if there are no enzymes, because enzymes are a substance that catalyze the chemical and biochemical reactions inside our body. It's not these proteins, nucleic acid, fats, DNA, deoxyribonucleic acid, okay, carbohydrates, a lot. I cannot mention everything, okay, this biochemical substances. This will not function properly without an enzyme inside our body. So, technically, we will die without enzymes. So, these are the purpose of this mechanism-maintained equation, that we need also to study the behavior of enzymes, how it will react inside our body, so that these substances, biochemical substances, will be effective to become us healthy, to give us energy every day to day in our lives here in the planet Earth. Again, thank you. This is again, I am a singer, eternal voice, OSH engineer, a chemical engineer. Bye-bye. God bless everybody. It's all about science. Thank you so much for watching. Romel Sacel and Maricel Cabral. Thank you so much. Ganon! Daoy. Baba na si June.